Hey guys, going live now on YouTube. I'm going to make a boost converter today, so feel free to join me and ask any questions you like about PCB design, and I will help you with your project. Hey guys, going live now on YouTube. I'm going to make a boost converter today, so feel free to join me and ask any questions you like about PCB design, and I will help you with. Hey, okay, cool man. Sound alright. So today I'm going to try build a boost converter. So I was asked by the community to make a buck boost converter, but I think maybe I'm going to take it step by step. So let's do a boost, let's do a buck, and then do a buck boost, boost buck. I think that will be quite cool. I want to make 3 different boost converters, being one that uses generic IC, one that uses Arduino Nano with a PWM, and then just one simple one. And then I want to make all 3 of them, and in real life, I mean with the PCB, and test them out on my workbench and see why we have all 3 different ones. So this is a very common circuit all over the internet. Great Scott made a lot. Hey Patrick. So yeah, let's try it. How did the circuit go yesterday, Patrick? Can you hear me? Hey Emre. Emre, I did ship it Friday. When did I send you the photo? Friday. So I don't know when you'll get it. Hopefully soon. It's a whole big mess. But yeah, I did get a track and trace. I must actually send it to you, and then you can also just track it. So today I'm going to make a boost converter. So I was thinking about making 3 different boost converters. So I see you get different ones, like with the 555 timer, with the normal IC, and with the Arduino Nano, and then actually just check yeah, which one's better and why we do different things. So I don't really do power electronics that much, so it's new for me as well. So of course I'm going to use the internet for help. But always I'm going to use Altium today. But guys, if you guys have any questions, I'm willing to go off topic as always. I actually just want to use this time to help you guys, so if we don't do the buck boost converter or the boost converter, it's fine. Cool. So let's start with a simple boost converter. Bots. We need a coil, right? Let's see what our options are. Don't think it's going to make too much difference. We need a Scotchy diode. What's the video title? Let's make a boost converter, episode 1. Oh, I spelled converter wrong. Too late. I can't change it now. Hey Krish, what do you mean, what is why? Oh, what is up? I'm making a boost converter today. That's what's up. Yeah, sorry Emre, if I have to change that now, I'm gonna have to go off and then redo it. So I'll just fix it after the last stream. But you know what it is, right? English is not my first language. I'm going to use that as an excuse. Cool. Step up converter, boost converter, what's the difference? So the first one I'm going to do is not, I need this is Scotchy diode, man. It's not going to be the IC version. I'm first going to do the Arduino Nano version with the PWM signal. And then we can have a look at what IC to use. I see they can use the, yeah, there's a couple you can see. Do you have any suggestions for an IC to use? I need a Scotchy diode. My spelling is bad. Can I just make diode? Just be careful about the diodes. So they just suggest the SR540. What specs is that? 40 volts, 5 amps. So you rather do MPS because it's not as common as TI, or what do you mean? Diode. So they suggest the SR540. Do we have any that's got a footprint? I'm going to have to draw it. Is this a diode? There's a fuse, man. Maybe my eyesight is bad. We can just go passive components. Yeah, but then, so MPS is not part of TI, right? So it's something different. No. Not too sure what voltage it should be able to handle. Don't think it's too much of an issue. Any sensor modules in mind for detection of incoming laser rays? Incoming laser rays? Laser rays from what? Like a normal laser pen, or what do you mean? Laser rays. What do you want to do now, Krish? How's the other projects going? You're full of ideas again. Laser rays. What do you want to do with the detection of the... Why is it? Doesn't look right. What do you want to do with it? So it says Kochi. Why is it so weird symbol? I want a nice symbol. What is your goal? What do you want to do? Yeah, I'm just going to take this for now. Right, so then we need a MOSFET here because it's the MOSFET that pulses that creates the boost. Oh, so it's like a laser tag. Emre, yeah, definitely. So you can go file export, I think. And then you can do step file, there's step 3D. Now Altium can do, oh, STL. There's hyperlinks. Yeah, you see, Patrick, we spoke yesterday about the hyperlinks. STL. Now you're asking me a question I never thought about. If I don't see it straight away, then my initial answer is no. But you can take for 3D printing, or yeah, STLs for 3D printing. Why would you want to do that? It's a very good question. Oh. Yeah, I can do step file, but why STL? Because STL is for normally 3D printing. Come on. It's my... Oh, it's IRF. Wow, there's not a lot of components here, eh? Yes, Krish. Oh, Emma, I think step file is probably the most generic. STL, what do you use STL for that you played around with? I'll have to think. Yeah, it'd be fun, right? I was thinking about doing the same in the grocery stores because I hate those trolleys. So if you can put lasers on it to play a game against each other and shock each other, that'll be quite nice. But I don't know what sensor. You can probably just look what they use for laser tag because it's exactly the same tag detection. Here's some stuff. I never read these cookies. So there seems like there's stuff on the website, on the internet. Infrared receiver. Can that not work? Can infrared pick up, what's a laser's frequency? Same. There's Arduino laser tag. There's a lot of stuff. This is basically what you want, Krish. Nice explanation. There's your website. It's very nicely done, step by step, code, everything. But yeah, you also, how far do you want to be when you shoot each other? But have a look on this website. Duino Tagger. That looks very nice. Cool, so then we need a I'm a member of a model satellite team. Electronics team will design a PCB. I'm a member of a model satellite team. Electronics team will design a PCB, which must be in the 3D design to go. Oh, okay. Wow, that's cool. Have you guys shot the satellite to? Have you shot one up yet in your team? It's a CubeSat, I assume, right? No, it's not a CubeSat, not a shot. I should not ask so many questions before you can type. Patrick, I do feel better in Altium. Not just the use, it's just the ease of movement and stuff. Yeah, it's just a preference. Especially with the PCB design part where I can hide layers. So if you like in KiCad, I cannot hide layers yet. But I guess I just know all the buttons. But like, if I just want to focus on the top layer, I can just push Shift S. If I want to hide the polygons, TGH. But I guess I'm just used to it. Where if I've got a board with a lot of layers and I want to just focus on the red, it's very difficult in KiCad. Where in Altium I just push Shift S, which I like a lot. The rules are better, things like that. But there's a reason why Altium's so expensive and KiCad's free, right? So you can't compare. But what you get for Altium for free, I don't think you can beat that. That is amazing what you get for free. But yeah, that's a different project. Let me open KiCad. If it can handle all this. So if I want to just focus on the top layer, yeah, but then I have to go here, right? I have to go here and just say focus on the front, and then I can hide it over here, that layer. Now I just want to focus on the front. So then I have to hide it here. So I can hide it. But that took me how many clicks? When Altium I can just go Shift S. So yes, it's possible. But yeah, it's just all my projects that's not completed, you can see with the nets and stuff. That's why, Krish, don't be like me. Finish a project. Like I keep doing stuff halfway through. But there's always a but. Really? Oh, nice. Ah, nice, Patrick. That's a game changer. That is a big game changer. Yeah, I don't like going with polygons. Just feels like it's in the way. This is polygon, right? Thanks, man. Control H. Yeah, then I would say the best part of Altium is the rules. You can't beat the rules in KiCad. I challenge you. I challenge you to create rules like you would in Altium. Hey, but anything's possible. But thanks, man. See, that's why I like this. I also learn. What's page down? Okay, that's just layers. That's just jumping between layers. Okay, I understand. That doesn't really help me. I know when you do a track and you want to push, you can push via, and you can just also go between the tracks. But the rules, so if I can go design rules, this you cannot do in KiCad. Yes, but not yet. When is KiCad 6 coming out? Nice, man. Switch to legacy. Switch to modern. Yeah, it helps a lot. If you can make sure your rules are correct, it just helps a lot. Your schematic with rules, your PCB will not be incorrect. Chances are very small. Then you can just make it routing. Yeah, but you have to realize they're doing it for free, eh? So you can't really be angry if they're late with anything. Hey Elias, how you doing? No, I've not, unfortunately not. I'm thinking about learning it so I can help people, because a lot of people are using it. Maybe I should download it. I assume you are using Eagle? Is there a lot of help on YouTube about Eagle or not? Maybe I should learn it for you guys. To learn Altium. Yeah, I guess. There's different aspects. So Altium's a bit bigger. Yeah, there's a lot of stuff here that I also don't always use. And Patrick, if you want to, let's say, I want to find Control H, guys. Lekker. So I want to highlight all these LEDs. So I've got 64 LEDs. How do I highlight it in KiCad? I'm looking for like find or anything. Is it possible? Yeah, KiCad is more than enough, I would say. I don't know if anyone on this channel has used Eagle and KiCad and can give a comparison, but I just can't see anything wrong with KiCad at the moment. Have you made a PCB yet, Elias? Shidar, I'm far from a genius. You couldn't be more wrong, but thanks, I guess. I'm watching because I'm related to electronic engineering. Are you studying electronics, or are you wanting to learn electronics? What do you want to learn and stuff? But I'm not a genius, man. What I do, anyone can do, I promise you. I've just used PCB programs for many years, right? So it's once you do things for many times, you just get used to using it. So in Altium, I can just go, it's not a competition now, but I can just go right click, find similar objects, and I can choose exactly. So I want to find all the LEDs. I'll make videos about this in Altium as well, and then it will highlight everything, and I can change settings. I think maybe I should. Okay guys, I'll keep Altium open if there's any questions about Altium, but I will move over to KiCad. I think most people use KiCad. Where's Find Similar? Do you guys want me to use Altium or KiCad today? I don't mind swapping. So let's just start a new project. We're going to call it Boost Converter. In legal way. That's true. No, it's fine. Then I will do it like this. Luckily, I didn't start too much. So push A. So now I have to get used to everything in A. Sridhar, what PCB would you like to make? Sorry if I say your name incorrect. Elias, you're always welcome to send designs to our group and stuff, and there's a lot of people to help. Yeah, I saw Patrick on Discord. Is that but you have to buy that book, right? Just going to use this for now because it's the same symbol, but I just have to change the value. Now I'm pushing space. Did you buy it? Did you buy the book that you shared? What's it called? Krish, I'll put it on Discord, yeah, no problem. So guys, if you want, you can join the Discord below as well. So Patrick and everyone's on there, and they like sharing ideas. Clicking space in KiCad, I don't understand. Ah. Yeah, I keep clicking space, yeah. I thought you meant click on the empty space. But yeah, I do click on space. So that's the only thing I need to just take a few minutes to readjust to the programs. Guys, like Elias and Shadar, if you guys have any questions about components, please feel free to ask. I don't mind going slow and anything. So if you guys are new to electronics, I don't mind explaining some components. So the idea what we're doing today is I'm actually just looking at this. So it's a nice channel. I'm going to make this buck boost, this boost converter. So basically switching this on and off through the Arduino, you'll be able to increase the output. So if I have 5 volts input, I'll be able to get about 50 volts in the output. Because this inductor causes magnetic charge and things like that, but I don't want to go too much detail. And then you can change the PWM with the potentiometer. So potentiometer just change resistance. Emra manufacture JL PCB and PCB way. So if I just do PCBs, I will do JL PCB, and if I do more complex, I'll do PCB way. Now I'm going to push place wire. And the thought process. In which way? Of making something, or which way of thinking do you mean? Yeah, I know the buttons, it's just I need to push it. I keep pushing place track, place wire, Altium P, and then you do what you want. But P here is power. Capacitors. Yeah, Elias, I hope we can help you then. It's a good way of thinking about it. Yeah, so capacitor will keep charge. I don't know, are you still a student, or? I'll draw the circuit and then we can go into it in more detail as well. But this MOSFET is just like a nice switch. So if I put a positive voltage here, it will open. It's an MPN. So yeah, so high here makes it open. Hey Nasser. Emre, depends what you mean by small. So if I have anything bigger than 0603, I will solder by hand, yeah. I do have a little reflow oven. I don't actually use it as much as I want to, or I should. Oh wow, that's a nice skill to have, and it can be both. It's good to know a bit about electronics, because you guys have to make the housings and stuff to protect it and all that stuff. I hope the video helped, Nasser. I saw your WhatsApp message, man. I was just sorry, I was a bit busy yesterday. So this will be the output. I would do that myself. Don't have an example here. It's actually not bad, Emma. If you I wonder. Okay, this is quite easy. This gets a bit difficult. This package is very difficult, so maybe I'll use a heat gun for that. Yeah. So if you actually have some flux, so what happens is this pad actually absorbs the solder. So even if you have a short, you can just add a bit of flux. The pads will actually, yeah, just go where it has to go. You can also use a wick if you have a short, but it's, yeah, just practice. Initially I was scared because you get bust shorts and stuff, but I should actually just make a video where I short everything and show how you can fix it easily. But I must say, for this, I do struggle with this a bit as well. But a heat gun does help, so it's a nice tool to have. But this whole hand solder, I guess, it's just time. And these LEDs are also horrible. But with JLPCB, if you guys do not a one layer board, but if you do a board with only components on the top, they will actually populate the components for you for free. So I do that quite regularly now. So if I order a board and there's some components that I don't want to struggle with, then you can do it. So what we got here is just a pull-up resistor. So what we're going to do actually is we're going to put a NPN transistor. That's the power. Do I have any examples? This, right? So this is actually version 2 of the keyboard with USB hub, but we'll get there. So you guys are talking about this, right? This type of package. That is actually not too bad. Just going to delete this. Which schematic? I've got so many. So what you can do is, there's videos as well, but use flux. Flux and solder gun is quite quick, quite easier. So these pads are made to suck up the solder with flux. So it will always want to go to the pad. If you have shorts in between, it's fine. You take some flux, you heat it up. It does fix it. If there's too much solder, you use a thing called a wick. So you use something like this, and you actually just heat it up, and this material will suck up the solder, and that helps very well. Yeah, you can ask Patrick. Elias, so I did study actually mechatronics, not this. And then in my first job, yeah, I just wanted to do electronics, and then I did this for a couple of years. Yes. How does the BMP look? Yeah, it's a bit tight. You're talking about that. But you can see, yeah, so flux, guys, flux is your friend. If you flux this and you just apply heat, the solder will go to the pads. The solder doesn't like to get stuck to the solder mask. That's why we have solder mask. So the solder will always go where there's pads. So that's why the vias are also closed. If the vias are open, the solder will get stuck there as well. Heat gun also helps a lot. And also, I see a lot of people make this with the iron for your clothes. There's a lot of videos about how to make your own thing. Patrick, you can ask, eh? You're welcome to ask about your properties. Oh, sorry, man. Okay. Yeah, I'm here. Yeah. Yeah, the part search is amazing. But also with KiCad, there's a lot of people who made a lot of libraries. So it's just importing, it takes a bit longer. Also, we made a video about using the, I'll have a look now after Patrick sees what he wants. Snap distance. Snap distance. Where do you see that? Oh, snap grid, snap distance. So the grid is, yeah, I'm just going to talk out loud while I think. I actually don't know off by heart. So the grid is this small stuff, and it will, so if I move this, it will snap every 5. So it's 1, 2, 3, 4, 5. It's 5 millimeter grid. So if I change that with G, it changes there as well. Snap distance. So it's 2.5. If I do it, it's 1, 2.5. I think the snap to electronic hotspot is just snapping to a piece. So if I turn this off, yeah, but it's on the grid, so it's a bit. Snap distance. I don't actually know. Never had to use it. I'll have to find that out. I think the snap to electronic hotspot is, don't do this guys, but sometimes by accident you put one component on a 5 grid. So if I do this, copy, and then I've got another component on a 2 grid. I'm trying to make it uneven because you can change the grids. So if I make my grid 1.1, it's 1. I'll just make it 2. Then by chance, I can make it 1.5. So now you can see I will never get on the same grid as this piece. But I think what the snap to electrical does, it will snap to a component, or not. There goes that theory. I would expect it to snap. Maybe if I place a wire. Yeah, okay, so that's it. Yes, so if you use a wire, then we'll go to it. So it's not the component, it's the wire. So yeah, my thinking was on the right track. So if by chance, but guys, don't do it, try to keep your components on the same grid, KiCad or Altium. And then you can see I will never be able to get to that spot because my grid's different. You can also right click and snap to grid, I think. Mod action. Somewhere snap to grid. But now with this snap electrical object, I can just go place wire and it will snap to it. Snap distance, I don't know. Maybe it's how far it's willing to snap. So if, yeah, I think it's that. So I think it's, so if I've got this component down here at the bottom, let's just get it back off grid. So I'm telling it, okay, come on. I think I'm telling it, okay, when I get 1 millimeter from this, snap. So if I change this to 5, it will snap earlier. Yeah, you see, I cannot even move. It snaps automatically. So it means it only starts snapping after 5 millimeters. Yes. Yes. Patrick, you understand now? I think we solved it. So this distance is when the wire will start snapping. So if I make it 1, base wire, and you see it starts snapping at 1. If I make it 10, I've got a feeling it's going to only start snapping when it gets out here. Yeah, you see. You understand, Patrick? I think that's it. I'm pretty confident that's it. It's a good question though. Yeah, it's just when you talk and stuff and you just go through it, sometimes it just happens. Miss something. The Tasteful Toasty, do you have any advice for reducing PCB turnkey costs? Place an order and receive a 10 protocols, but the total cost is £500. So you're British, I assume. 4-layer controlled impedance with assembly. Yeah, PCB is expensive. Do you have components on top and bottom layer? Thinking now what can be best. And all your components are SMD. You don't have mixture of through with SMD. That will increase your price. 4 layers, normal. I'll have to think about that. Hey, yes, sorry, I didn't see a message. I was busy trying to solve the adventures of the snap distance. Okay, so can you guide us about how to make a charger for different batteries according to battery specification? Yeah, said what battery? So I do have a YouTube video about how to make a charger for a LiPo 3.7 volts. But if you can give more detail, what type of batteries? Yeah, it cannot be smaller. Altium license, yeah. So I do actually have a link that you can get a 6 months trial from Altium. Patrick, I don't, if you're my Instagram, I need to start doing stuff properly on my, what is at the bottom of this video? Yeah, so in the links below there's a thing called, man, I just saw it and I can't even say it. Download your free Altium Designer 20. There's a link there. So if you click on it, you can go through processes, and then I think you get a 6 month free version. The Tasteful Toasty, if it's only SMD and top layer, I would go to JLPCB. So if you, because I did the same now, so I'll just, so if you have this, so I made this board as well, so so this board I also only on top. Okay, I've got this, but I'll hand solder this. Yeah, so it's not made by PCBWay. They also want to charge me like 600 euros. JLPCB does production as well. So they do SMT assembly, but only for one layer. So if it's only top, you will save about a quarter of your price. Just find out if the impedance matching stuff, I'm not too sure what they do. But yeah, at the bottom you can just say SMT, and then you can do stuff 4 layer. I know they can do 4 layer, but is it a Tasteful Toasty? Is it a serious board like for a customer, or is it a hobby? Or yeah, there's a bit quality difference. So PCBWay is more expensive, but I do find their quality is a bit better. Gel PCB will work. I use them all the time like this to save money as well, because like I said, PCB design is an expensive hobby. Hey DIY Electronics, how you doing? Yeah, see it, I've got a video on YouTube about LiPo batteries. We made one. I actually have a design in our Github that you can just take. But LiPo batteries, there's no specification because it's the milliamp hours, right? And all of them are about 3.7 volts. So there's an IC that just does all the thinking for you, so you can't overcharge it, you can't short circuit it, things like that. So yeah, Toasty, I think I'll go for JLPCB. I don't know what you exactly want to do, but they assemble for, yeah, actually the assembly cost is like 20 euros or dollars, I think, so it's kind of free. I got a quote from PCBWay and it was 500 euros, and then I got a quote from JLPCB, same board, and it was 150 euros. So yes, okay, that's true. That's true. If there are other parts, they can't assemble it. Oh yeah, my link seems broken. That's a very good point. Broken? Strange, eh? It adds like a question mark at the end. Just delete that. That's weird. I'll just put it. Yeah, 500 euros. It's strange. In the link, if you push GitHub, it says Bumpot 55. You click on it, then at the top you get like this a question mark. But if you delete that, you'll just get there. Yeah, strange. No, what's a MMT charge controller? What is MMT? I can Google it. So it's like solar charging. Okay, so I'll have to look at it. I don't know it off by heart. What do you want to do with it? Toasty, I don't know where we can get cheaper. So it will follow the solar panel. So it will follow the sun with your, depending where the sun is, your thing moves to capture the best sun, right? Patrick, it doesn't matter. I just come online to help. I can actually like if I want to, I can make a YouTube video about this, right? So it's not really about, this isn't my main goal. There's more chatting to you guys and seeing where I can help. And whatever we achieve. But then I'll make a separate YouTube video diving into this, giving you the schematic, giving you the Gerbers. I don't think so. Battery max charging voltage 8.5. What battery, I said? So when I talk about a LiPo battery, oh shucks. I'm talking about a battery like this. What battery are you talking about? It's a protocol to ours. Oh wow, that's nice. So we should combine it actually. Use that plus automatic tracker of where the sun is. That might actually be a nice project. I know they exist. One of my friends made it for his final year project at university. So I'm quite interested what battery you want to use. 8.5. You can't charge this more than 4.2. Maybe I should make a new battery video for a different battery. Guys, I like these questions. Like I said, this circuit I'll kind of just do on the sidelines. I will always make a YouTube video afterwards, more detail. But it's more about us chatting and trying to help each other, getting to know one another. Elias, yes I do. I'm a South African, but I live in the Netherlands. You saw by the .nl and the Dutch. How did you know? Go to the boost. That's 3.7. Maybe you have two of them in series. Then it makes sense that it's 8. Because 4.2 times 2 gets you to 8.5 almost. Because yeah, it's the same what you said. No, it's not. But anyway. Yeah, sir, you can. Do you have my WhatsApp number? But let me just place a component before Patrick shouts at me. Where are you from, Elias? Oh, nice. How's things in Sweden? That's not too far from us. Never been, always wanted to go. Well, welcome to the channel. Hey, Dragos. We were supposed to go to, just for New Year's Eve, we were supposed to go to Lapland. And then there was like no restrictions. It was going to be amazing. And then the day before we were supposed to fly to Lapland, yeah, they just cancelled and now we need tests and stuff. And then, because we were supposed to go to the Sweden part of Lapland. I was so excited. Very sukhoi tsune. What does that mean? Are you Swedish, Elias? Depends who's listening. This circuit has no reverse polarity protection now, I think. I didn't even focus on that. So this will go to my Arduino Nano. So it depends how we switch this MOSFET on and off, will depend on the voltage we get on the output. But now we also have to, we can make it smart by putting a feedback to our Arduino. Oh, that's cool, man. Swedish Finnish. Yeah, we got some very good friends from Finland. From Finland, yeah. We went to Helsinki last year. It's amazing. So it's one part of your family is Swedish and one part Finnish. Who's not Finnish, right? The Finnish word is Somali. What am I doing now? Focus. Sumi, yeah, there we go. That's it, Sumi. I watched the World Cup ice hockey finals with my Finnish friends. That was quite exciting. Yeah, we just shot for ice hockey, Elias, because between Finland and Sweden, it's quite sensitive topic. Okay, so now we're gonna put yeah, guys. So this channel we chat about anything. Now we're gonna put a feedback to our Arduinos, because what I want to do is, let's say, how can I say it? I've got 5 volts in here, and I want a 12 volt input always on the output. So sometimes you can take different loads, and that load will determine what the output voltage is. So I want my Arduino to read what the output voltage is, and then change the PWM to make sure that my output voltage stays constant. Does that make sense? Because this is the quite interesting part. So what's going to happen now is I've got an input. Let's say I've got 5 volt input. We're going to make it maybe a 5 volt USB input. Who knows? This is just a text. It has no real meaning. So I've got this 5 volt input, and I'm going to change this to switch this MOSFET on and off depending on different speeds, and then this will determine if I get 5 volts to 50 volts on the output here. But now let's say I plug in a LED or a different type of load. The load can make my output of my voltage vary, so I can then get between 11 and 13 volts, which I don't want. So I can put a feedback loop on the output back to my Arduino, and then Arduino will sense that my voltage is not stable, and it will self-adapt to the PWM, kind of like a PID loop. I hope that makes sense. But what you have to know is the Arduino can only handle 5 volts, so we need a voltage divider here to drop this voltage down. Make sense? So this is also dangerous what I did here, guys. You can see this is one wire. It's not good practice to make one wire have two labels. So if I push L, I create a net label. That means that this point is connected to this point. So I give this one line two names. Here it is fine because I've got components in between. So it's not shorted. But this is not, so we can actually just make this, it can work, it's just not ideal. So what I like to do is, everyone has their own preference. So they have to have a common ground. Just push C, JP. Oh, place wire. So what we want to do is drop this voltage down by using a thing called a voltage divider. So we can go up to 50 volts, so almost like 10 to 1, but let's say 42. Okay. I'll show you guys here as well. So let's not try VRS. So if you go on the internet, you get a voltage divider calculator. This is a nice website. So I basically create this. So I've got a source and then I've got a voltage output. So if I've got 40 volts, and I always read a voltage with respect to ground. So I will read this voltage across the R3 resistor. So I'll read this voltage. You always read a voltage with respect to ground with the Arduino. So if we make this 8 and make this 1, what do I get? I get about 4.4 volts. So that's why I chose those values. If I do 50, it's a bit high. Then I can change this to 10 and I'll get 4.5. So changing these two resistors, you can drop down the voltage. So it's almost like a buck circuit, not really. Just you can't really use it like that because you have to think about the power and the currents and stuff like that. But this should be fine. It's also a bit noisy. Cool. I hope that is clear. I think it's basically almost dead, right? Now let's just get a nano involved here. Hey Ranesh, how's it going? What do you mean after so long? What do you mean? What are you trying to say? Cool, so let's just I'm going to change this as well, guys. I don't like stuff like this. This is a power source. It should be a power source. I'm going to make it 5 volts because I want to. No, the Arduino can use it as well then. I'm good on yourself, Ranesh. Guys, and don't forget that we are doing that, helping someone once a month, eh? So just watch the previous video, I think, and then we can, yeah, help someone once a month with a project by sponsoring them something. So this just means that this line is connected to this line. I just like it, it's neater for me. I think we'll get about max about 50 volts on this one, but I'm gonna keep it to about 36, 40. I'll try to do 60 and blow it up. So I'm gonna make this PCB. Yes, sorry, yes, it will change by the PWM. Depending on the PWM, depends on the output you get. It has to do with this inductor. So the inductor charges and then it creates a magnetic field. Magnetic field gets feedback back in the system. The capacitor with that just creates this extra charge. I'll make a video in detail trying to explain everything, but there's a lot. Great Scott made a very nice explanation about it. There's a lot of nice videos explaining about the boost converter. But what I want to do is I want to make it on a PCB, and there's different ones. So you can make one with 555 timer, you can make one with the IC, and I actually want to see on an oscilloscope what is the difference. Why can't we use this all the time? Is the efficiency just bad? So it's just for me a learning, for us a learning. Ranesh, that's very true. That's very true. Keep good filtering on the input and keep the loop as small as possible. No, Ranesh, I don't think this is not a buck boost converter. This is just a boost converter. I think a buck converter will have another switch on top here somewhere. And you get rid of, this is not a buck boost converter. We'll get there. So I first want to do a boost, a buck, and then a buck boost. So I'm really trying to take it step by step. I don't know why they do this. No, Ranesh, I appreciate that you're helping. That's why we have this channel. But yeah, I just don't think it will buck. I want to get a buck, but yes. Yes, that is the main difference. You are correct. So let's look at the picture. Oh wow, this is a different battery. There's a LiPo battery, rating voltage 7.6, max charge. I actually think this is just a LiPo with 2 in series, right? Is this part of a laptop or something? Where do you get this? Yeah, you learn a lot when you start breaking stuff. Where do you get that battery, I said? Doesn't seem like a hobby battery. Laptop. So why don't you charge your laptop in a laptop? It's difficult. Maybe I can. I can put on Discord and then I can show the Discord. Can't show my WhatsApp here, I think. I can, and it just takes too long. I'll do that now, guys. How do you know it's not the battery that's the issue? Do you try a different battery? Let me see. So this is the battery he wants to know. So laptop battery. Yeah, so it's 7.6. Okay, so it's not the battery, it's the laptop itself. Yeah, I'm just thinking because buying a new battery will probably be cheaper than making your own PCB. I think it's probably just 2 in series, right? A lipopolymer battery pack. So the pack means there's 2. I'll have to think about it. Maybe there's a circuit where you can charge 2 S batteries. But I wonder if someone hasn't made this already and can just buy it off Amazon or something. Because to be honest, guys, making your own PCB for stuff like this, it can be more expensive if someone has already done it on Amazon. Just get it from there. If you want to learn, that's different. But for practical reasons, it's not cheaper. Yeah, this is lipo. Yeah, see, did you try a different laptop battery or not? I'll have to have a look. I can't think of. You can make a circuit for 2 S LiPo batteries. You can just use an IC. Maybe I should try that. But like I said, it can be more expensive. Let's just have a quick 8-volt LiPo battery charging. Yeah. My advice would be to look if something like this exists. That can do it for you. Because like I said, if you want to make it yourself, it will be more expensive. I'll have a look at what circuit we can do and then, because I know that people with the drones also want something like that. Yeah, you must just be careful. Just because this is 8.2 volts, don't just apply 8.2 volts to it. It doesn't work like that. It's like you can't take a battery LiPo and just put 3.7 volts on it. It's about trickle charge and all that stuff. So guys, this is just a potentiometer, so if you turn the dial, you will change the resistance. VN reset. So this is not an IC, this is actually the little Arduino Nano board. So I don't need voltage regulator, I don't need USB, things like that. Got ground, I got that. I need my feedback. Also in analog. Hey Hardik, how are you doing? Come on. Wrong way. Ah. Cool, I think that's basically it. So we're going to have 5 volt in here. And by changing the PWM that we get from the Nano, we can change the voltage output up to, let's say I'm going to try not push more than 40 volts. So 5 volt input, changing the switches on. Then I'll be able to change the output. I've got a feedback with a voltage divider to make sure that I sustain a certain output that I want. And then a potentiometer to change the PWM to a certain voltage that I want. I think that's it. Now let's just make sure that I've got footprints for everything. Let's see what I have. Tools updates. Guys, what time of streaming is suitable for you guys? So suitable. What's ideal time for you guys? Because I know some of you are in India, and you guys are pretty far ahead. I think 3.5 hours. So. What's the time by you now? 9 o'clock? Ah, JP, did you save? No, you didn't. So guys, now's the time to ask questions because I'm not touching this thing until the non-responding goes off. No. Patrick, does your KiCad ever do this? Or is your PC just better than mine? Like I know if I click now, it's going to go not responding. It's going to exit and I'm going to lose everything. I didn't push the save button once. What? Does your KiCad ever crash when you go update schematic to the PCB? But I think it only happens when I'm streaming. I don't know. I'll wait for 5 minutes. So how's everyone doing? How's your Sundays? Yes. In the Netherlands, there's a curfew every day. Thanks, Toasty. But guys, always save. So I'm going to do that now. Save. That's an interesting Hardik. Hey Elias, no problem. Yeah, I'll try be. So I'll probably have to leave here about 4:30. Do adult stuff. Now I've got some Dutch homework to do and stuff. I'm planning to organize a PCB design competition. Hey, Sanay. We trying to, for who is this competition? For experienced designers, for students, for what is your target? Hey Andrew. I'm all over the place now. I'll think about it. Let me know if you want me to. Oh, Travis, Hardik, let me know if you want me on Instagram to let people know about your competition. I really don't mind. Wait, Patrick, you said I must do something. Preferences. You said tools. One minute. Oh, there is autosave. That's good though. Okay, now we must just make. Trevor's a lucky logo. Yeah, I just want to help the people as well, eh? Hardwick, so I don't mind. Hey, Dougster. I need to set Git up. Yeah. I'm just lazy, man. I don't have any excuses. I'm going to use it for this. I'm going to use through all capacitors, capacitors, resistors. Should be fine. Gonna buy. Ah, jealous, man. Are the guys gonna come over, or are you doing it alone? Bras at barbecue, guys. So in South Africa we call it a braai. Do you guys braai every Sunday, Doug? A few cold ones. It's a Sunday. It's a Sunday. Okay, I just need to make sure that I've got all my footprints. Now we'll put on the 3D step files soon. Why do I have to? Yeah, I'm missing something then. Something's not right. There's one. Where's the other one? Oh, this MOSFET. Emre. So it's different for me. In KiCad, I will search for the, I think Altium, I would search for the real part number because I know it's in the database. With the resistors, yeah, so I'll put a resistor and then depending if I want SMD or through all, I'll choose it here. I always, but rather do it in your schematics. So rather make sure that all your schematics has footprints. You can go here and put a footprint also by pushing O and then link it like that. But when you update, then it's not always that nice. So I always advise people rather just make sure that your schematic has footprints. It looks nice. So what is going on here? Ideally, you would make the NPN and everything perfect here. You'll know exactly what component you'll have. Like this is a MMBT22AL. This MOSFET is, I'm not going to use this one, I need a bigger one. So if you look at my schematic Q2, it's this. And this is way too small for this power and stuff. So what I'm going to do is have a look. So we need a IRF Z44. So I want to use something like this that's bigger, just for heat dissipation and stuff. Yeah, so it's a nice big boy. But now this footprint, that I'll have to draw it myself, so you can see there. Or what I can do is I can try to find it. So is there MOSFETs here? Why don't they, what do they call it then? fiducials. Why am I missing it? Switches? Will it be under switches? MOSFETs? So what? Because I can't search here, or can I? Battery, can I search here? Because I can search here. Just make sure everything's closed. What? Yeah, yes, it will be. But what bites me in my behind is when you start mixing stuff and you want people to populate it, then creating a bomb gets a bit of an issue. So I'm trying to cut corners. I was wondering, do you know if I can search here? So if I go here and I want to choose a component, can I search in this box? Because I know I can search into the PCB. Like, yeah, I can search. So if I go voltage regulator, there we go. Yeah, I want to try find a package. But I want to search for a package. Like if I want that 220, how do I find the 220 here? And what's it called? Yeah, they do. We can put a heatsink underneath, I guess. One of these bad boys. I'll just do... Yeah. Oh, wow. Patrick, this is amazing. Search. Yeah. I still can't search. That's cool. I assume it's here. This is pretty cool. Yeah, I'll play around with it. I just want a search option. This is quite nice. It's nice that you got all your stuff here. So now I will take, okay, but let me, you have to do this by your own. This got changes. So what I'm going to do now is the other method. So I'm going to take this. There's more than one way to skin a cat. I'm going to go here. And I can change this to Q2. delete this to Q2, and now I should be able to link the two by going tools, update, reassociate, and now it's linked. It's very cool. I've got this bomb thing, this plugin, but that's only afterwards to generate it. Very, very cool. Get some pictures on this. Okay, so that's cool. I think that's everything. Not. That's on there. That's on there. That's on there. Just going through it, look, making sure I got everything. Nice. Cool, now we can start. Sort of. So what I like to do is I always try to go like the schematic left to right. So I've got a voltage that goes to a resistor, that goes to inductor, to a transistor. That makes sense. So your schematic and your PCB goes hand in hand. So let's just move this out the way. Now if I click on it, there's my inductor. We need a voltage input, right? Can I put it? No, I can't do it. So do solder joint. Just so I can make this. I need somewhere to put the voltage in, right? So place a part, test point. I just normally do test points. Place part. So many different ways of doing stuff. Oh, let's just do it like this for now. So if I make this TP1 and I make this TP1, then they will be linked. So that's important in PCB design, making sure your schematic and your PCB is the same. So that can be my voltage. I can make this bigger as well. We probably will. And then my ground. Always have your ground pointing up, down, and your voltage pointing up. It's just technically makes no difference. It's just nice to have, preference wise. Tools, update, reassociate, update. There we go. So from my input, I'll go to my inductor, I'll go to my resistor. Why are you not connected? So the problem here is this resistor, if you look at the symbol, I wonder if I can get to its part. You can see it's connected, but it's no net name. The reason is this P$1 and P$2 is not the same name as what the creator of this symbol called these pins. So there's two ways of fixing this. So it's looking for 1 and 2, and not P$1, P$2. I chose the wrong one, man. I should choose resistor through hole. It's much better. I'll just make it just biggish. So if I zoom in here, you can see it's 1 and 2. So that's the problem. So when you ever get an issue where you're trying to update and the connection here is not the same as here, make sure that your name of your component on your PCB connector point names is the same as your one you created here. So this one is P$2. I don't know why people do that. This is 1 and 2, so this should work. Just think about the distance. So I'm going to take this and just copy it all over now. Tools, update. And now it added. I missed one, R1. There we go. So R1 is going here. So like it is in the schematic, you try to make the PCB the same. Goes there, goes to resistor, goes to there, goes to my MOSFET. This will make routing also much easier. I don't need to know this. Goes to my sketchy diode. This has to go to the resistor. Potentiometer. voltage divider. Let's have a look what we can do, how to make it look nice. We need to output right as well, so I'm doing this because I need to be able to have a way of outputting our voltage that we just got. So the idea is I put a voltage in here and I must get a voltage out somewhere, so I just copy this. We want this test point 4. Test point 3. Probably make it a bit bigger, it's a bit small. Now we have to be careful about, so when you start working with higher voltages, the gap between tracks are important. The clearance and creepage, this distance becomes important. Don't think the current will be that high, so the current track width, we'll try to keep it as thick as we can. Let's just make a board outline, edge cuts. Don't want to see this on the PCB, so I don't want to see this. So let's have a look if we can find some step files. Save, save. Getting old. Yeah, okay, so this should actually be quite easy routing, not a lot of stuff. Go to my trusty GrabCAD. I'm going to update the step files now. It's DWG. You can't use a DWG, can you? 3D settings. Can you? No, you can't. Emery like this. Yeah, so if you push Alt 3 you can get there, but what I'm going to do now is I'm just downloading all the step files for these components because I would like to see the components in real life. I just like it, it looks so nice. Of course you can order the board without this, but for me I like it. We do have lots of videos about how to do step files, how to do all that stuff. So I'm just quickly going through it. I was actually just make sure that it's pin 1, where's pin 1? I can just type in 90 here. Oh, it's the wrong side of the board. So that's how it'll look, guys. So you can use this to make sure you get a proper view of everything. And then if you want to be very serious, you can start typing in 0.1 minus 0.1, 0.2, 0.1. Doesn't seem even. Anyway. And now if you go Alt 3, it should be there. How nice is that? I will just make sure the first thing, no, I think it must be the other way around. I must actually just look at the nano schematic, but I'm assuming that is pin 1. It looks so nice. I just love how you make it in KiCad, you order it, and it looks almost exactly the same. To think the effort people did to make this so it looks nice for us. And it's free. Crazy. People don't always realize looking at this how much time this guy took. Robotronic. So I use GrabCAD and I just downloaded all my step files. Look how nice this is. What a man or lady. Yeah, I think it's the other way around as well. I need to double check. Put one. I'm assuming that's pin 1 on top. Yeah. No, 1, 0, 2. How does this work? Luckily you solder yourself, so you can always change it around. But I'm gonna just swap it around because I feel it should be the other way around. Might be wrong. Not like a minus 180. I should be able to see, right? Because that's the USB. Isn't that the USB? No man, it was right. What do you mean for the footprint? I can always rotate this. So either rotate the footprint or the thing. So that should be right. Yeah, that's right. That's right. What are we missing? So missing a coil. Yeah, I also didn't see the USB port. I only saw it now. Swing. And always check that you guys download the step file, not SolidWorks parts and stuff, because then you just waste time. That's not going to work. What also helps if you double click on this, you can see normally what footprint they mean. You can just search for that. It's not this one. Nope. It might be this one. I'm just downloading some step files. So guys, make use of GrabCAD. It's really a nice website. For mechanical as well, I guess. The step file. Okay, they do step files. It's just different lengths and stuff. I like green. Green's my favorite color, so let's try this. Is this even right? This is not right. I need to get the correct one. Almost thought it was. But anyway. Massive. Let's start routing. I'm losing the plot now, but oh, we haven't done this yet. So let's just tools update. Okay. So what I'm going to do is my output. So when I spoke about your creepages, so when you look at, so this is clearance. So clearance is from one point to another, and then creepage is the actual distance. So it's the same as in distance and displacement. I think it's the same as that. So yeah, you can. This tool will give you at 40 volts. Yeah, not to worry. I need to have 0.16 millimeter clearance. Always try to look at other places as well. Yeah, so 0.6. So it also depends on what signal you are in the layer it's coated. So you need 0.6 millimeter clearance for 40 volts. Just to keep it safe now. So it depends also on, is it coated, what environments it's in. But for now, let's just, maybe we can keep it at 1 millimeter. Then we're definitely safe. But you're always as weak as your weakest distance. So this capacitor is 1.7. Okay, so we really don't have any issues with voltages. So that's always something to keep in mind, is you're always as weak as your weakest distance. So everything can be 5 millimeters apart, but if this is not 5 millimeters apart, then there will be some jumps. Make this nice and thick. See how easy it is to route now that everything's in line. No real issue. I will choose capacitors that manufacture these voltage. Yeah, I think this is a 50, I think it's about 200, 300 volt capacitor. I must just check. So if your output voltage is 50 volts, don't choose a 50 volt capacitor. Don't choose a 60 volt capacitor. I always try to maybe choose double the voltage. But Emre is a good point. Let's see. Yeah, see, this is 25 volts, so this will never work. Just want to check for 47 should be fine. Like this, 35, not good enough. So now we can go here, SMD. Safety first always. Go 160. Yeah. So this one, 160. That should be fine. So in KiCad, I normally just do this because at the end I go through my BOM. Let's actually just check if the footprint matches there. Should. P. Okay, depends which one we choose. There we go. $125. So here you can see the case size is J16. J16. So we want just to make sure that I'm pretty sure it should be fine. 6 difference. 6.7. No, that's not going to work. We measured 1 point something, so this is all wrong. Hey, I am sentient. How you doing? No, that's not something's not. Netflix. You guys want to watch Netflix? So there, P is 6.7 millimeters. That's a big capacitor. Hey, yes, I've got both open. So if anyone has questions about any, I'm just using KiCad now because I think most people like KiCad because it's free and then everyone can learn. There we go. That's fine. Why doesn't it have... One's plus and minus. One's plus and minus here. Strange. Yes, it is 6, but I'm trying to... I don't know why people do this, man. So this schematic symbol is created with a plus minus annotation, so not a 1, 2. So if I go tools, update, reassociate, and I say, that doesn't matter. And then you can see it says here, C1 paired minus not found in the drawing. So it's because it's not minus, it's 1 or 2. So it's not plus, it's 1 or 2. So it's giving a problem with that. Let's try something. That's why it's always... Yeah, I'm trying to rush a bit now because I have to leave like in 10 minutes, and then ideally I would always just make my own footprint, because everything's perfect. How's this through hole? Let's just take this for now. I'm gonna fix it. I actually have a Snap EDA. So if you go here, external plugin, Snap EDA. So you can just go to here and then choose what you want. So if I want, do they have it? Yeah, they don't have the part. So there's a nice library for KiCad as well. You can use a through hole, I guess, as well. But you can see on the side here, it doesn't have all the parts. Yeah, but then Mauser does it. Yeah. Yes, I can do it, yeah, I guess. Really? Do you ever use this down in ECAPS? I've never done it before, actually. Because then it looks different. Then I'm gonna have like pink and stuff, but I guess it doesn't matter. Let's try it. Let's see what happens. But you have to convert it, right? Because it's a different file extension. EPW. Can I when you don't know, you just Google. Yeah, but then I have to use a library loader, right? I don't know. So it seems like I have to use this library loader to change to a file that works for me. And then I can do what I know and just import, which is fine. Seems to be nothing wrong with it. Must you buy it? I don't. No. Yeah, so we must just keep in mind to change this. 6 millimeters is so much. 6 millimeters is very, very big. For Eagle, you also have to do the whole conversion thing. I must delete this, man. And it works fine, but you have no issues with it. There's not too many mistakes with the with the libraries. What I'm actually going to do is make a copper ball. That's good. That's very good. And you have a preference between Snap EDA and that website, or don't you see a difference? Oh wow. I guess that's nice, because then you just order the components from Mauser and then everything just lines up. It matches quite nicely, I guess, because Mauser won't give you a footprint, or they shouldn't, that doesn't fit their product. Cool guys, unfortunately I have to go. I'm going to finish this up, so I'm going to fix this capacitor. I'm going to try use that program that Emre suggested. Maybe test out Mauser and how to import it. I've not done that yet. And then I'm actually going to probably finish this up and then order this board tonight or tomorrow. And then with JLPCB, I should be able to get it before next weekend, and then we can test it. And then next week I will make the buck version of this, or the buck boost, we'll see. So I want to do the boost, buck boost, and then just test. Also want to try different ones. So the one with the IC, because you can actually buy IC that's a boost IC. And I would like to test efficiency. Why can't I do this? Why do I need the IC? Why do I have to spend more money? So it's something I want to play around with, connect the oscilloscope to it, see what the differences are. Cool guys, but unfortunately I have to leave now. Yeah. Thanks for joining, really appreciate it. Guys, don't forget, we are doing that once a month thing where we guys help you with a project. Hey Siri. I can prototype it. The thing is, I've got an order coming from them, so I can add this board and it will cost me $2. I can prototype it, so if I catch it in the correct time with the order, I don't have to pay shipping. So, yeah, so guys, if you have any questions, please just message me on Instagram, Facebook, YouTube. Most of you have my WhatsApp number as well, so don't worry about it. You guys can message me. But yeah, so we're having that the 1st of April, we will choose a project that we'll sponsor. So we're sponsoring a project every single month now, just to celebrate the monetization. It's not like, it's not quite my job monetization. I think yesterday we made $1. It's just fun, exciting times. But yeah, so email us with your idea and we'll choose one 1st of April. And then let's build some projects. No, thanks you guys. Cool. Cheers. Bye. Till next Sunday, same time, same place. Let me know if I need to change the time, or the day is a bit difficult, but the time I can change. Cool guys. Bye.